In this video, we're going to talk about glycolysis, which is a series of enzyme catalyzed reaction. If you're in a hurry and cannot watch a whole video, then I would jump to the overview part of the video. Feel free to jump through the video anytime, again, if you're in a hurry. Also, I'm probably not gonna pronounce any of the chemical names right, so bear with me. Alright, so we start with dextroratory. I can't pronounce that, but let's just say declose for the sake of this video. It's a product of photosynthesis due to glycogen processing. Alright, so in step 1, we have phosphorylation occurring. So we use 1 ATP for this, and essentially a phosphoryl group is taken. We get ADP. Hexokinase is an enzyme that is used, and the phosphate group is attached to the D-glucose. And as you can see, D-glucose turns into D-glucose 6-phosphate. And we have manganese right over here that kind of shields off the phosphate group negative charge. And yeah, that's pretty much what happens in the first step. Alright, then we have the enzyme phosphoglucose isomerase. So this enzyme, it essentially rearranges a carbon-oxygen bond to turn glucose 6-phosphate to fructose 6-phosphate. So it's an isomerization reaction. So as you can see in the image, the 6-membered ring turns into a 5-membered ring through the rearrangement of the carbon-oxygen bond. Right. Moving on to step 3, we have phosphofructokinase. So phosphofructokinase essentially turns fructose 6-phosphate into fructose 6-biphosphate using 1 ATP. So it's kind of similar to step 1 in that phosphorylation is happening. We also have the use of like manganese and stuff. So as you can see, there's another phosphate, hence the name biphosphate. Next in step 4, we have aldolase. So the aldolase, the enzyme, it turns FBP, short for fructose biphosphate. And in case if you're wondering, I'm going to use a lot of abbreviations because of the long names. So you can refer to the slides or just look at the screen and you'll know what I'm talking about. So it turns FBP into DHAP and GAP. So DHAP and GAP, they're like isomers. So isomers to each other. And so now we have, as you can see in the photo, we have 2 isomers. 2 carbon molecules. I apologize. And now in step 5, we have triosphosphate isomer. I cannot pronounce that. Okay, we essentially have this complicated named enzyme turn DHAP into GAP. So now we end up with 2 GAP molecules. Alright, and then in step 6, which is very much complicated step, so we essentially have this enzyme called GAPDH. So for this part, GAPDH, essentially what it lets NAD do is that it lets it take hydrogen off GAP. And this leads to the formation of NADH, and then the phosphate group then reacts with GAP to get 3-biphosphoglycerate, and a hydrogen atom is the result. So the products essentially, to put it all together, is 3-biphosphoglycerate, NADH, and a hydrogen atom. Remember, there are 2 carbon molecules from step 5. So kind of like throughout this video, from like I believe step 6 to step 9 or to the end, what will happen is that you'll pretty much repeat these steps twice in a way. I'll explain it later on in the video. Alright, and in step 1, we start making some ATP. So in this process, PGK, or phosphoglycerate kinase, is your enzyme. So the biphosphoglycerate gives ADP, basically essentially a phosphate group, and then this gives us ATP. Again, we have magnesium used in this. I have no idea what that says, magnesium. So we have magnesium used to get the negative, for the negative charges of the phosphate group, to help with that, to help with shielding a little bit. Now remember, from step 5, we had 2 carbon molecules, so now we have 2 ATP over here too. And so the final product is 3-phosphoglycerate and ATP. Alright, so step 8 is pretty much what PGM does, or phosphoglycerate mutase, is that it takes away a phosphate group from the 3rd carbon, essentially, and it adds a phosphate group to the 2nd carbon, hence the name 3-phosphoglycerate to 2-phosphoglycerate. You can kind of see the chain if you just follow the phosphate group in the picture. As you can see, it's on the C that's a little bit lower than the 2nd C, and it kind of jumps up in a way that, if that helps you, like, kind of, understand it better. Alright, so step 9, so we're super close to the end. We have enolase. So enolase essentially dehydrates the 2-phosphoglycerate and yields a water molecule along with the phosphenol pyruvate. So we're like super close to the end here. So really it's just it's just like looking at the water, because dehydration, it's pretty simple. You just get a water molecule and you just take off essentially like hydrogen and stuff to get a water molecule, and then you have phosphenol pyruvate. It's a pretty simple step, I would say. Alright, so this is step 10, the last step. So we have pyruvate kinase. So that's an enzyme here. It essentially takes a phosphate group, gives it to ADP, and that forms ATP, ADP to ATP, so essentially. And then you have your pyruvate. So we have to remember that from step 5, again, like I said, that we had 2 carbon molecules, 2 GAP or GAP from step 5. So remember that, and remember repeating the step twice. So if you do repeat the step twice and follow along on the video, you should get results of 2 ATP, 2 NADH, and 2 hydrogen atoms. 2H+. Alright, so now let's go into the quick overview. Okay, so step 1, we had D-glucose to D-glucose 6-phosphate with the help of hexokinase. So we had phosphorylation occurring over here. With step 2, we had glucose 6-phosphate to fructose 6-phosphate. And this happened through the rearrangement of carbon-oxygen bond, which happened via with the help of the enzyme phosphoglucose isomerase. Now in step 3, we had fructose 6-phosphate to fructose 6-biphosphate with the help of phosphofructokinase. And this is kind of like step 1. We use 1 ATP in this. Just like in step 1, we use 1 ATP. In the 3rd step, we also use 1 ATP to get that phosphate group. Hence the name fructose 6-biphosphate. Now, when we jump into step 4, we have FBP, or fructose biphosphate, 6-biphosphate, to DHAP and GAP. The enzyme here is aldolase. It's essentially a breakdown of fructose 6-biphosphate, and that's what it yields. Alright, second slide. Alright, so step 5, we had DHAP to GAP. The enzyme here was triose phosphate, and yeah, and then we're gonna jump straight into step 6, which is GAP to 3-biphosphoglyscerate. And this is the enzyme here is GAPDH. So remember, this is the process where I recommend really to go back to the section because it's probably the most complicated, and I can do justice by just like going over it like in 20 seconds. All right, so step 7, biphosphoglycerate to phosphoglycerate, and this is done by the enzyme phosphoglycerate kinase. So over here, the 2-ATP is formed. So ADP phosphorylation. So ADP is essentially given a phosphate group, and that turns into ATP. So we have it occurring twice because of the 2 carbon molecules. Remember, we had 2 gaps from step 5. And next we jump into step 8. So step 8 we have 3-phosphoglycerate to 2-phosphoglycerate through the enzyme PGM. And this is done by the addition of a phosphate group. Remember, on the 3rd carbon in the chain, we have a phosphate group removed and we have it added to the 2nd one. Again, if you want like an image, I would jump to the section in the video. I'll have everything divided into sections once I post this video. So hopefully that will help. Alright, so this is the final slide of the quick overview. So on step 9, we had 2-phosphoglycerate to a water molecule and phosphenol pyruvate. So the enzyme is enolase. I probably did not pronounce that right. But anyway, we'll go with whatever I said. We're dehydrating the 2-phosphoglycerate, and that's why we get the water molecule and the phosphenol pyruvate. So next we have step 10, which is the last step. And we have phosphenol pyruvate yielding 2-pyruvate and 2-ADP. So this happens from the pyruvate kinase, which is the enzyme here. It takes a phosphate group and then it gives it to ADP. Now remember, when we're talking about the steps, remember the 2 carbon molecules. Always go back to step 5 where we had 2 gap. So that's why we have 2 ATP here and 2 pyruvates. So if you guys remember, so let me go back to the results. So if you guys remember, we had 2 ATP used over here, and then we had 4 ATP made. So this is the net result. So this isn't like, all the ATP used. And yeah, that pretty much sums it up for this video. Thank you for watching. Please like and subscribe. All right.